Good afternoon, I am Mr. Ish. We have recently looked at integration of rational functions utilizing the polynomial long division technique. In this video, we're just taking that one concept one step further by me providing you a useful tip when it comes to integrating rational functions. When we're doing a rational functions and we're doing a integral of it, and let RF be a rational function, the best tip I can provide you is exactly this. Simplify your rational function prior to your entire procedure, because that simplification procedure will make this entire process much more easy. I want to provide you two good examples in this video which will drive this specific message home. I want to reiterate my tip to all of you: always simplify rational functions prior to any kind of procedure, asymptotes, derivatives, antiderivatives. Let's look at the very first question of this video. And the very first one is a rational function which looks something like this: 5x cubed minus 2x divided by x squared plus x dx. We have to do the antiderivative determination of this. If you were to simplify it, you would bring out the x in the numerator, and then you'd have a 5x squared minus 2. In the denominator, you'd bring out the x, you'll have an x plus 1, and then a dx. You see that simplification? And then the x's cancel out, so in essence you're looking at a 5x squared minus 2 divided by x plus 1 dx. Remember, rational functions are very common and pervasive when it comes to integrals. And now you'd have to do the polynomial long division, so let's do it. And it's not going to be hard by any means because you know how to do that. X goes in 5x squared, 5x times multiplied back, you'll have a 5x squared, you'll have a plus 5x. I just added the 0x as a placeholder. When you minus it, this cancels out. Here you get a minus 5x minus 2. X goes in minus 5x minus 5 times, and then you multiply it back, you'll have a 5 minus 5x, and then you'll have a minus 5. You can minus everything over here, it'll switch the signs around, and here you'll have a 3. So you end up getting a 5x minus 5 plus 3 over x plus 1. This right here is my remainder, and everything over here is basically your new integral, your new integrand. And this integrand is very easy to integrate because of this simplification procedure that we have undertaken. Look, you can complete it now, everything in your head. 5x becomes a 5x squared over 2. Minus 5 becomes a minus 5x. Remember, n plus 1 divided by n plus 1. This becomes here plus 3 natural log x plus 1, close the natural log absolute value, and this right here is your answer, your antiderivative. If you wanted, you can do a common denominator across or common denominator here. In this instance, you do 5x squared minus 10x over 2 plus 3 natural log x plus 1 plus c, and your answer is complete and your answer is good. Our second and last exemplary question for this video is this: x cubed plus 1 divided by x squared plus x, rational function. Simplify it and then proceed. Factor out that numerator. X cubed plus 1 is a cubed plus b cubed. You'll do x plus 1, then you'll do x squared minus x plus 1. Remember the factoring? That's exactly where this is coming from. And then you have x into x plus 1 and then dx. And here is your factored out rational function. This will cancel out with that. You'll essentially end up with just x squared minus x plus 1 in the numerator, your numerator polynomial, and here you just have an x dx. Now you don't have to do polynomial long division. You can separate everything into their separate integrals if you want, but you can individually carry this out in your head. You're looking at an x squared divided by x, that's an x. You're looking at a minus x divided by x, that's a minus 1. Then you're looking at a plus 1 over x. You see, what I've done is separate everything under their own denominators, and things canceled out along the way. Now when you look at this, the antiderivative is very easy. It's a polynomial. From the x, you'll generate an x squared over 2. From the minus 1, you'll get a minus x. From here, you'll get a natural log x, and then plus c. You can again do a common denominator here if you want, and we can do that. My common denominator here with the 2 affecting only this part would be x squared minus 2x all over 2 plus natural log, and then you have x and then plus c, and this right here is my final answer, and it completes this video. Remember, when you're looking at rational functions, always simplify the rational functions by cancelling, by isolating, by factoring, by whatever means necessary, because then your simplified rational function is very easy to integrate. Granted, there are situations where the rational function, like I've presented in the previous two videos, could not be simplified further. Those question forms were still slightly challenging, but still polynomial long division simplifies the rational function integral procedures. Thank you for watching. Stay tuned. Have a nice day.